I'm going to go over the code that I went over in class, just basically it's cleaned, user space, basic queue. This is what it looks like. So pretty. But basically, we have a basic queue, we have our locking, unlocking, we have the producer, we have the consumer. And I've added color coding just to make it easier to see. Yes, everything is displayed in bright white colors because I am blind. We have our PID, which tells us this is the process. All the threads within this application should have the same. However, their thread ID will be different. As you can see, this is 28, this is 08, this is 48, this is 68. They vary. Now let's get into the code and how I implemented this user space. Okay, I broke out my code. This makes it clean, easier for me to make changes and follow through. I don't want one file that has everything, makes it very long, not so clean. I start with my usual standard C libraries. I'm including it, pthread, errors, so forth. This is an additional thing that I added. It allows me to have these beautiful colors. You don't need that in your code. Now I have struts. This is for creating the node. This is for creating the actual queue, including the locking mechanism. This queue is implemented as a linked list. I have a front and I have a rear. The functions that I have created include creating the actual queue, deleting the whole queue that I created, and I'm able to add a node into my queue, and I'm able to delete that node from my queue. And then the functions that I need for acquiring and releasing my locks. Here. So this is just a very basic queue. Here's the header functions. Now let's look at the implementation side. Again, I am calling my .h file because everything is declared there, so I don't need to declare it in here. I start with setting up my acquiring and releasing of the locks. Again, this is already built for me. I don't need to think about it. What I need to do though is ensuring that I can call and check to see if I can acquire the lock, and I need to test that and test that. But I've added a bunch of print functions, as you can see, not print functions, just print statements, so that you can see, like, here is this specific thread trying to acquire the lock. Here's this thread that released the lock, and so forth. Makes it easier to see. And this is user space, so we're using printf. So my code for acquiring a lock, my code for releasing the lock, and then I have my function that will create an entire queue, including making it dynamic. So by calling malloc, I'm setting my front and rear. I'm initializing my lovely locks. I've also initialized this condition. This basically allows me to have a more robust locking instead of just having the lock acquire and release. I also want to add and to ensure that all of the conditions have been met so that I don't have any leaking. And some of you guys might run your code in Valgrind and you'll see that there is about like 4 bytes inside of a block, and these are not within your code implementation, it's outside of your code, so I wouldn't worry about it. But adding things like this, like conditions and so forth, just makes your code overall more robust. I have a helper function that checks if my queue is empty or not. Here's my first set of code for adding a node. I am creating a node. I'm adding the size. So I'm adding memory or custom memory. I'm checking to see that I was successful. If I was, I'm adding the data, metadata to the data to the node, and then I'm pointing it to the next node and setting that to null. Then I'm trying to acquire it. I am acquiring a lock because I am trying to now add this to my queue. So I went ahead and I created my node that I want to add to my queue. And now that I'm ready to actually add this node to the queue, that is when I try to acquire the lock. I don't try to acquire the lock beforehand. Doesn't make sense. So I try to acquire the lock. I'm checking if it's empty. If it's not, then I'm adding it. And then I'm also going ahead and printing everything I need, because adding is part of the job of the consumer. Here I am just printing that out. I'm adding the condition to say that whatever I was trying to do was successful. Once it was, then I go ahead and release the lock. Now I'm into my next function, which is the dequeuing. This is much different than enqueuing. I'm not creating anything. I'm immediately going in and trying to delete something from my queue. So I'm going to have the lock at the very top. I'm checking if it's empty or not. If it is, I go through, create a temporary node that points to the node next to the one I'm trying to delete, so that I can go ahead and delete that node. And then I free memory. I'm printing out information because this is what the job of the consumer, and then I'm go ahead and I'm going to release the lock. My condition is over here. This is basically saying that if I'm in here, I'm waiting for the lock. So if the queue is empty, that means my condition's already been met, so I should unlock. And then finally I have the function that deletes the entire queue. Again, I'm going to lock the whole thing. Do the same thing, creating a node, a temporary node, and trying to point it to the next node, delete that node, and do that in a loop until I delete every single one of them. I'm going to release it, then I'm going to destroy the locks that I initialized, because this was resources that I took from the OS. And then I'm trying to finally release the entire queue, because I use malloc to actually create the queue. So this is all the functionalities of the queue. Now I'm going into my main. My main is calling my queue. I actually don't need this stuff. I don't know why I have it in there. But I have a main function. Inside of it, I'm creating my queue. Then I am initializing 4 threads. The first thread is the producer. A second thread is a producer. Second and third are consumers. And then I'm going through a loop and having them do their jobs. So whenever this is happening, once a thread 0 is created, I call the producer function. It goes up to here, the job of the producers. I need to create a node, and then I need to add this node to my queue. I have this function specifically so that things aren't going so fast. I can slow down and be able to see. And then once I add 2 things, I call 2 consumers. The first consumer will go in. If I added the 7 here, then this consumer is then looking at the queue, and then it tries to go and remove it. It's just dequeuing. Adding this again to slow things down for us to visually see. Again, I'm not returning anything because this is a void function. These are void functions. But yeah, and then once everything's done, you delete your queue, you print that everything was complete, and you return 0. Again, the output look like this. Adding things, deleting things, adding, delete, add, delete, acquiring the locks. Here's the actual location of the locks. But yeah, now that we have the user space, APIs that we created, as well as our locking and so forth, and tested everything, next thing I'm going to show you guys is how to actually create your wrapper functions and turn all of this into system calls.